Hi, my name is Michel Dufresne. I'm an independent consultant in the New York City area specializing in rule-based business application. This is a three-part series in which I describe how we can use the semantic web technology for specifying the domain model of a rule-based application. In part 1, I talked about how we can use the web ontology language as a modeling language for specifying the domain model. In part 2, I talked how we could bring together the description logic formalism with the logic programs formalism in order to write rules on top of ontologies. In part 3, I use this as a foundation to build a model-driven architecture for building the business applications. The web ontology language is a W3C standard that builds on top of RDF and RDF schema and add more vocabulary for describing classes and their properties. OWL come in three flavors. There's OWL Lite, OWL DL, which stands for description logic, and OWL Full. OWL DL is of particular interest because it is based on description logic. This provides maximum expressiveness while ensuring that all logical deduction can be computed. A class describes the set of individuals with common characteristics. A subclass corresponds to a subset of the parent class. For example, if you have a class that is defined as the set of all of the individuals for which a property A equals 5 and a property B has any value, then a subclass in description logic can be defined as the subset of those of this set for which all the individual has a value of B equal 2. The subclass must fulfill all of the axioms of the base class, in this case A equal to 5. In object-oriented, we don't have the exact same type of semantic. Actually, in object-oriented, a subclass can redefine the semantic meaning of a property of a base class. In this case, for example, in object-oriented, you would be able to declare a subclass for which A equal to 3, so we would redefine the semantic value of that property. This would not be admissible in description logic because the individual of the subclass is not a subset of the individual of the base class, because the axiom A equals 5 of the base class is no longer respected in the subclass. So description logic is based on a formal logic-based semantic. Consider, for example, class A and B, then you can define the union as all of the individuals that belong to class A or class B, while the intersection would be all of the individuals that belong to class A and to class B. And the complement of class A could be defined as all of the individuals that do not belong to class A. OWL distinguishes 6 types of class description. The first type is a class description can be in terms of a class identifier, which is known as a primitive class. For example, male and female can be defined as primitive classes. Also, a class can be described in terms of an exhaustive enumeration of all of the individuals of the class. So, for example, the class day of the week can be defined as the class that has exactly 7 individuals, each representing a day of the week. Also, a class description can take the form of a property restriction, either on the value of the property in the form of an existential property restriction, which means that there exists at least one property with a specific value or a value of a specific type. And a universal constraint would describe a class for which all of the properties have a specified value or are of a specified type. Also, property restriction can be on the cardinality of the relationship between two classes. So it could be in terms of a maximum cardinality, a minimum cardinality, or a specified cardinality. Also, a class description can be in terms of the intersection of two other classes. And a class can be in terms of the union of two classes. And also it could be in terms of the complement of a class. So these class constructors or class description can be used to build class constructors in terms of class expression. So for example, the class D can be defined as the intersection of class A and class B. So for example, the class Impressionist painting can be defined as the intersection between the French painting style of late 19th century and the artifacts that has a paint stroke of unmixed color. So more complex expression can be built. For example, we could define that an Impressionist art collector is defined as the intersection between a art collector and all of the individual for which there exists at least one artifact of type Impressionist painting. And as we just saw on the slide before, Impressionist painting is defined as the intersection of two classes. So you could build fairly complex class constructors all from using a very simple set of operators. So this concludes the first part of the presentation, and on the next part I will talk about how we could bring together the description logic with logic programs, so to build rules on top of ontologies. Thank you.